Hello, I'm Mark Licht. I'm an assistant professor and cropping systems agronomist with Iowa State University Extension. And today, joining me here in a little bit will be Adam Janke. He's also an assistant professor, but he's a wildlife specialist. And we get to work together on a number of projects with the Conservation Learning Group. Today, we're going to talk to you about this one project in particular called Redefining the Field Edge and how do we deal with unprofitable areas. Okay, so we know that there are a lot of different conservation practices out there. Here we're just highlighting some that are put together in the nutrient reduction strategy. A lot of these are in field. There's some edge of field, some that require land use changes, things like that. We know that there's a lot of them out there. And we're trying to figure out which ones do we choose, and then how do we look at these on the landscape, and how do we look at how they benefit not only the productivity, profitability aspects, but also the conservation wildlife aspects. So as we think about this, some of these that do require some land use changes might be a little bit on the smaller scale, less intrusive, like prairie strips. They may be on the edge of the field. They may be through the middle of the field. Or you can think of some of these land use changes in more of a larger scale perspective, such as subfield plantings of perennials. We commonly know these as the Conservation Reserve Program. So they may be cool seasons, they may be warm seasons, they may have mixtures in them. A lot of times these are on the field edge, but they're in the order of 5 to 10 to 20 acres or more type thing. And so what we're wanting to look at in particular is how do we think of some of these aspects that are maybe smaller scale, which traditionally did not have the opportunity to be enrolled into any of the government programs, but in recent years that has now been allowed and things have opened up a little bit there. We know from a subfield profitability standpoint that there's a lot of Iowa cropland that does not make a profit or generate a profit. We know that there's a lot of variability from one year to the next. Traditionally, we think of, as far as the depressional areas, we think of north central and central Iowa, but then there's also these opportunities as we think about western and southern Iowa, even into eastern and northeastern Iowa. So we know that there is a strong economic case for how do we manage some of our fields a little bit differently? How do we walk through that a little bit? And so, the case for redefining the field edge has been made through a lot of different publications. Here, what we're really highlighting and wanting to talk about in this slide is really looking at the nutrient aspect of it. And so we know that especially in the areas where we have depressions, denitrification does occur. And what we're really talking about there is when we have water meeting carbon and given enough time, all of a sudden we start to denitrify. The other aspect of this is that a lot of times these depressional areas, we see nitrate losses that are many, many, many times greater in annual row crop areas versus perennial areas. And so this is just another aspect of how we can manage these areas a little bit differently to be beneficial on all different aspects of the landscape. So what we're going to go through today here a little bit is we're going to first start out with where do the opportunities to redefine the field edge exist and how do we find those? And then we'll transition over to Adam a little bit about how can we establish these perennial vegetation in the opportunistic areas, and then what happens when we do establish that perennial vegetation in those areas. So that's kind of the plan of attack here for the next several slides. So just starting right off with where do these opportunities exist and how do we find them? So this really comes down to doing profitability analysis. And profitability analysis is not really a new thing. It's new in the last 20 years, most certainly. And we have various software packages that make this really quite easy to do, especially if we're using yield monitors and on-the-go type monitors to collect our field data. So what we're really talking about at a subfield level is using our yield and assigning it a market price, and then subtracting out those input costs. Now, obviously, from a subfield profitability standpoint, we want to be using as much spatial data as we can. And so definitely we want to be using the yield monitors on those combines and exporting those maps into this software. Using the actual cash price for the crop is going to give us a more realistic view. Although we can use other sources like USDA NAS. They do a market year crop price. And for our study, that's what we use for market price. And then with the input costs, the more we include, the more accurate the subfield profitability is going to be. So every time we're going out there across that field, we should be recording what's going on and using that type of information. Again, if we're using variable rate seeding or spreading phosphorus, potassium, lime, nitrogen, if we're spreading that at a variable rate, using those maps helps give us this fuller, more robust picture of what the subfield profit loss is going to be. So I'm going to show you one of the 4 farms or fields that we did this on to give you an idea of what it looks like and some of that breakdown. So to set the stage here, this particular field, we have data back to 2011. It's in a corn-soybean rotation. You can see there that along the eastern and southeastern corner, there's a Eagle Creek that goes down along it. Okay, the difference there between, or the difference between the profit and of the green areas versus the yellow areas, that's depending on the year, that's between $75 and $90 per acre. Obviously, the loss is where we have a negative profit occurring there in the red areas. So this is the map for corn in 2011, and you can see that there's a few areas there that are not in production now because they have prairie strips going down through them on the eastern side, and then along the creek on the eastern southeastern side, that's also in a warm season mix along there as well. Okay, so switching in, look at 2012, and this is obviously a dry year. And so some of the areas that we would traditionally think of being depressional and low yielding or low profit don't show up here. 2013 corn year. This is a year in an area that we had a lot of precipitation in the spring, and so you can see some non-harvested area off in the western, southwestern corner, and then over on the eastern side there. These areas they did not have a stand, and it was non-harvestable. You can see there too along the southern and eastern sides where profit was quite low. 2014, the soybean year, now you can really see a couple areas that were non-harvestable there in the southwest part and along the southeast corner where we had flooding that really reduced the soybean stand to a level that it just was not harvestable. 2015 corn year, nothing really stands out there to note. 2016 soybean year, you can again see the same 2 areas along the southwest and the southeast edges where we had low profitability, and an area where the yield map on the monitor and the combine was not recording quite properly. 2017 corn year, those areas look, the areas that were depressional and lower yielding in the soybean years, here they look quite nice. 2018 soybean year, again, we see those same 2 areas where we have lower yields, lower profitability. Okay, so just to give you a quick shot of one of those areas that was non-harvested, and you can really see what has occurred here. So these 2 areas tend to be, in this situation, these 2 areas were the areas that he chose to pull out of row crop production for this project, and then he put them into a CP23 conservation mix that has a nice mix of grasses and forbs in it. And so there you can kind of get an idea for area and what he was able to take out. So I'm going to show now on 3 of these fields kind of what the profit loss breakdown looks like across time. And so the top one there being Calhoun, and then the bottom one in Wright County, you can see there's a predominance that we had basically no profit being made. We were in the negative more times out than we were profitable. And quite honestly, in those areas that we took out of row crop production, the years where we lost money were not able to be recovered in the years that we did make money. So in other words, year in and year out, across time, those areas were just overall non-profitable. And that happened in our study here in about 52% of the site years. Obviously, as we went through that Wright County sites and went year by year, you were able to notice that it tended to be the soybean years where the profitability was the lowest in those areas in particular, right? And so one of the things is obviously with this being a depressional area where we have water standing, we have water coming up or draining into those areas. Soybeans are just a shorter plant, so they can't withstand the ponding saturated soil conditions nearly as well as corn can. So we tend to see that of the 52% of the site years that were operating at a loss, the majority of those were soybean years because of that. Okay, so at this point, we're going to take and transition over to Adam, where Adam will talk a little bit more about how we establish these perennial vegetation in those areas.
Hi, my name's Adam Janke. I'm the Extension Wildlife Specialist here on campus, as Mark mentioned, and I'm going to be talking about the second part of the survey where we're looking for what are the opportunities or the secondary impacts of redefining the field edge, and how can we go about maximizing the potential for those secondary impacts, specifically as it relates to, in this case, I'm going to talk about wildlife, but of course, Mark already introduced the important context for water quality as well. So what we want to ask is, once we've identified these areas that Mark mentioned in our fields where we're not profiting, what are the alternatives that we could do with those areas? And specifically, we want to explore how we can establish perennial vegetation. And what we're going to talk about with perennial vegetation are what term will be diverse native perennial vegetation, which is to distinguish it from maybe perennial crops, which are also an opportunity, just one that we're not talking about today in this presentation, or also other types of perennial vegetation like exotic grasses like reed canary grass or smooth brome. What we want to consider or entertain in this talk is establishing native vegetation that has benefits for both wildlife, water quality, and the farmer or landowner, rather than maybe a more homogeneous stand of exotic things like reed canary grass or smooth brome. So, how do we establish diverse native perennial vegetation in these areas once we've identified them? Well, another part of this research project that Mark has been talking about is that we went out and asked professional wildlife biologists and natural resource managers what they think about what are the barriers and what are the opportunities for establishing diverse native perennial vegetation mostly in wet areas in crop fields. And so we did that with a survey, and the details of this aren't necessarily relevant. We just kind of wanted to have some transparency in showing you this slide, how it is that we came by the recommendations that we're going to present to you. So we sent out this survey to professionals that establish and maintain diverse native perennial vegetation on farms and on natural areas across the state. We had 51 different respondents from the DNR, nonprofit organizations like Pheasants Forever, county conservation boards, universities like Iowa State and UNI, and private entities. And they were all telling us how it is that we should go about establishing diverse native perennials in wet spots in crop fields. And so here's the recommendations that they came up with. First, the establishment process will take some work, but that work on the front end will pay off by having a strong established stand on the back end. And so there's a 5-step process in these early establishment phases. These are the same general recommendations we have for establishing diverse native perennials in row crop fields anywhere. But in these wet areas, there may be some special care to or special considerations to make for dealing with the flooding that we'll talk about. So first, learn the site conditions and history. Make sure that you know about residual herbicides. And the best case scenario is to follow a soybean crop. That'll create the nicest seed bed. Pick the right seed mix. So we'll talk about that on the next slide. Prepare the seed bed. Most of the time, planting into a soybean field is a pretty good way to establish prairie. You don't need to do a lot of site prep, but sometimes, depending on the condition of the site, you may want to disc it or cultipack it. Plant the seed properly. This is a really important thing anytime we plant prairie or native perennials at all. Remember that the way Mother Nature plants prairie is by just dropping the seeds on the surface of the soil mostly over the winter time. And so that's what we'll commonly see as a recommendation for these areas. And we don't want to plant it too deep. Many prairie plantings fail because we try to plant them a quarter inch or more into the ground, and those seeds just aren't designed to germinate that deep in the ground. So we want to just barely scratch them into the surface, or even just frost seed them onto the surface of the ground with a broadcast seeder. And then we want to have consistent mowing in the first year, and that'll be important in establishing these perennials. Perennial plants grow down, annual plants grow up. And so in the first year of a perennial stand, we want to help the perennial plants grow down by fighting the annual plants, the weeds, that are growing up. And so we want to do a consistent mowing 4 to 8 inches high, about 3 times in the first year as site conditions allow for you to get in there. We asked these professional wildlife biologists and other natural resource professionals what they recommend for a seed mix in a planting in a wet spot in a crop field, and to have the most benefits for both water quality and for wildlife habitat. And their recommendation was about a 50% mix of grass and forb seeds. And the grass and forbs should also include about 30% sedges and rushes. And so there's lots of species. We're going to show you those. Here's a couple of common sedges or rushes mentioned. 15 different species of grasses were mentioned by the respondents. The most common was prairie cordgrass and big bluestem. Both of these are adapted to wet or intermediate wet sites and will thus do well in a planting in a wet area in the crop field. And then there was a ton of forbs mentioned, and forbs are, of course, just a word we use for wildflowers. And there's over 300 different species of wild flowering plants, woody plants, grasses, sedges, rushes, and forbs found in Iowa's prairies. So we have a lot to choose from. 98% of our respondents mentioned swamp milkweed, and that's just a point worth making, is that in order to have secondary benefits like benefits to monarch butterflies in these areas, we do want to put something like a milkweed in there, and swamp milkweed would do well in a wet area. But also we just want a diversity of flowering plants available out there throughout the year. The good news is you don't normally have to pick these things yourself. You can go to a local seed dealer from one of many native grass and forb seed dealers in Iowa and throughout in neighboring states that sell native plants. And oftentimes, Mark mentioned this, that you can find a CP23 flood-prone mix on the market that fits the conditions that our wildlife biologists and other natural resource professionals suggested in their responses to our survey. So you can just get a mix off the list that's designed for a wet spot, and it should have success if you follow those establishment recommendations. The next thing to do is, once you've established it, and about after the 3rd year, you need to start to remember that these areas will need some active management to try to keep them in diverse native perennial vegetation and avoid losing them to like annual plants or losing them to exotic species. And so 94% of the people that filled out our survey, those natural resource professionals, mentioned that you need to do some sort of follow-up management in the site. So it's really important. And most of them actually mentioned using prescribed fire. And so prescribed fire in the middle of a crop field could actually be pretty manageable. It wouldn't require a lot of sort of technology and wouldn't present a lot of risk. But there are, of course, natural resource professionals like private lands wildlife biologists with the DNR or Pheasants Forever that could help with that. And many rural fire departments also will help with prescribed fire. And you want to think about doing that every 3 to 4 years to try to keep the diversity in the site and keep the competition from invasive plants down. Lots of other methods to manage these areas. We're interested in grazing if there'd be potential for that, and that might be a way to also control the vegetation. Occasional haying or mowing, and maybe even disking or interseeding could also be used to maintain the diversity and maximize the benefit of these areas once we establish native perennials there. Of course, there's going to be lots of challenges in these areas depending on their size and how often they flood. The flooding may just present a barrier to establishment of the native perennial vegetation in these spots, and that'll be something we'll have to learn about and try to sort of anticipate in our planning. Invasive species are a consistent problem, and that's why we want to start with and give the native seed a really good chance to get established, and that'll fight invasions from things like reed canary grass. Herbicide drift from applications to adjacent fields, access to management. If they are in the middle of a crop field, it may be a barrier to managing and mowing during the growing season, and then maybe some of the expenses. And so those were the things that the wildlife biologist brought up, and we just want to sort of emphasize that we're aware of those. We're going to learn from those as people start to reevaluate options within crop fields and redefine the field edge for themselves. And we'll get help from those professional wildlife biologists, county conservation board staff, and others, the types of people that answered this survey out in communities across the state. We wanted to acknowledge that some of these challenges may look a little not what we're expecting to find once we convert them from row crop, non-profitable areas in the row crop field to as we try to establish perennials. Here's a picture from one of the areas that we studied where the seeding was not successful. And as you can see, it's basically a monoculture, homogeneous stand of giant ragweed. That's what we're trying to avoid. We're trying to avoid something that has a little bit better footprint of perennials. And so there's a couple of different options to do that. Following those recommendations that we just mentioned will be a big help, and learning as we go. So we want to ask, what happens when we establish native perennial vegetation in these opportunity areas and crop fields? And we wanted to basically try to describe the benefits that will accrue once we take these areas that we're already not making money on out of crop production and put them into diverse native perennial vegetation. So one, we asked the professional wildlife biologists in that survey what they thought. And here's their responses. The blue is the best improvement, substantial improvements, and the dark blue. And then the lightest color is no impact at all. And you can see that as a general rule, these wildlife biologists that were surveyed thought doing this in crop fields is going to do a lot of good for a lot of different things. It's going to be good for monarchs. It's going to be good for native bees, hunting opportunities, bird watching, pheasant habitat, grassland bird habitat, northern bobwhites, and white-tailed deer. This is kind of roughly ordered in terms of the species we think will benefit the most. And the species that are going to benefit the most are those that are kind of able to use these small patches in crop fields. Monarchs, native bees, and pheasants will definitely benefit. And then the neighbors, or if you like to hunt yourself, could also benefit from some of these areas as well. We also did some monitoring on our own. We actually found 4 or 5 farms here in Boone County, pretty close to campus, that we've been monitoring for the last couple of years to study how birds and how monarchs and the resources monarchs need, like nectar and milkweeds, do in these areas when we identify them and take them out of crop production and put them into native perennial vegetation. Here's what one of those fields looks like. It's a half of a section of land with 62 acres of native perennials established in it. Here's another one. Just for context, I'm just going to fly through these farms that we've been working on. Here's another 200-acre field with 20 acres of redefined field edge. Another field with 120-acre field with 20 acres of grass. And here's actually a whole section of ground that has 67 acres of grass put into wet areas. We went out into these and did bird surveys in the mornings during the summertime when a lot of grassland breeding birds are here. And we found a bunch of different species that are called species of greatest conservation need. Those species of wildlife that we're actually most concerned about still surviving in Iowa's landscapes are doing quite well out here. We found some, in every one of these, we found dick thistles and eastern meadowlarks. And in some of these, we found some rather rare grassland birds like bobolinks and sedgerins doing pretty well, singing in these areas. We also found a bunch of other species that aren't those species of greatest conservation need. And in total, 22 different species of birds found in these areas of crop fields that were once just not profitable and today are growing birds. We also sent that crew of interns out to search for milkweeds, monarchs, and flowering plants for resources for the monarch. And so here's some of that data. This is this is a picture from one of our field sites, and you can see that there's lots of milkweed thriving out there. And we did the way that we researched this was to measure the distance from random points to the nearest milkweed. And that allowed us to estimate that there's about 70 stems of milkweed per acre out there, which is exciting because that's consistent with what we anticipate in sort of national planning efforts for the monarch for wet areas of CRP to provide. So that was an encouraging finding that these areas in crop fields can have pretty high densities of milkweeds that the monarchs will take advantage of. We also had those interns and staff look for monarchs on the milkweeds themselves, and we found that we surveyed 1,300 stems, and 6% of them had a monarch on them. This is either an egg or a larval stage, and that's pretty consistent with what we find in other studies. Is it takes a lot of milkweeds to grow a couple of monarchs, and so we need a lot of them out there. And the fact that monarchs are taking advantage of these areas is really promising as well. And then finally, nectar resources. This is just the diversity of flowering plants found out there, which ideally we want to find flowering plants throughout the year. And we found that on average, from a random location in one of these fields, you only had to walk 6 meters or about 7 yards to find the nearest flowering plant. That's pretty good if you're a monarch or a native bee. That's good to find that your food sources are in these areas, which is pretty exciting. We also did this evaluation to just sort of understand how much of the field was in annual plants versus how much of the field was in perennials. The dominance of annual plants may indicate challenges. So like, for example, here during close to this intake for the tile that used to be in this part of the field, this has been modified to come up higher out of the ground than it would when it was in crop production. But we find that there's a lot of annual plants in these areas that are really flood prone. And so what we found is about 9.5 or around 10% of these areas in the field were dominated by annual vegetation, which means the other 90% was perennial vegetation, which is exactly what we're going for, because that's the best for both the wildlife communities that we were studying, and also it's best for the water quality benefits that we know will accrue when we take these areas out of annual crop production and allow perennial plants to grow there. So that was a promising result, even though we found some of those really bad places, like I showed you that picture of giant ragweed. That was the exception, and the norm was certainly favoring the diverse native perennial vegetation that we want to see in these areas in the crop fields. So now we're going to go back to Mark. Mark's going to talk about some of the water quality and soil benefits we've seen, and then wrap it all up with our thinking on what we're learning from this project.
Okay, so like Adam said, I'm going to take over here and talk a little bit about the soil nitrates and some other benefits that we can see. And so what we're really looking at here is at the 4 sites that we have, we did nitrate sampling down to 12 inches once a month from mid-June through October. And, we did these in both where we had converted into that CP23 mix and in the row cropped areas. And so the Calhoun field was cornfield, and then the other 3 were soybean fields. The interesting thing here is that a lot of times that perennial mix, even though we were just getting it established, had lower nitrate levels. Now, obviously, with the corn, we would expect that just from the standpoint that we did not apply nitrogen to the CP23 area, whereas we would have to the corn crop. But even in those soybean fields where we had no nitrogen, the perennial areas were lower nitrate. Now, part of this is because generally, well, for all of these sites, I guess, when we seeded the CP23, we also seeded some oats with it. And so those oats do take off and they dominate really in that June and July timeframe before we get to that first establishment mowing time period. As we get into August and September, you can see that we do have some areas that we did not have samples in the row crop fields, largely because of drought conditions. We just could not get a soil sample taken. And so that's why we don't have differences there. As we get into September and October, again, we were able to get our soil samples taken. The interesting thing here is unintentionally, the Calhoun field, which is going to be corn again next year, had already been harvested by the time we took the September samples, and the nitrogen had already been applied. And so you really see a spike in the nitrate level in that corn operation. But again, in the CP23 mix, very low still, leading to large differences, right? So we know in these areas that we convert into a perennial vegetation, they're going to have much lower soil nitrate levels because generally speaking, we're going to have biomass. And as we repeat this again next year, our intent or our hope is that we see more of the perennial species taking over and continuing that trend. The other thing that we see as far as benefits to having this perennial vegetation out there, not only is it from a nutrient reduction loss standpoint, but within those areas, we're greatly improving the soil health. So we're improving the infiltration, the soil structure, soil porosity, soil organic matter, those types of things. So generally speaking, we would not say that those areas that where we're making that conversion and improving the soil health, we generally don't think that that would have too much benefit on the neighboring row crop area. One area that we do think there's some benefits is because of the increased infiltration and drainage where we are converting. We do think that will help drain some of the marginal area right around the edge of that depressional area. So we do feel like there's going to be a nice balance and trade-off between the row crops and vegetation, and then also being able to get some of those wildlife benefits as well. Wrapping up here, we really think that this is going to be a very promising opportunity to redefine that field edge. It will give us that soil, water, wildlife value, and not have a detrimental impact to our row crop production or row crop profitability. In fact, while only marginally, we think that the profitability will improve overall across that field from a field-wide standpoint. One of the things as we've been starting in on this, now these small areas can be enrolled into some government programs to provide some cost assistance there too. So that will just add a little bit more kind of gravy to that system to make it work, be a little bit more enticing. We do know that we do need to have more education and we need to have some more long-term technical support behind this. The farmers in the state of Iowa have been very, very good and efficient at planting corn and soybeans as we've increased those acres and we've reduced the number of small grains and other crops that we might have in the forage world, right? The detriment of that is that we've lost some of the knowledge base around how do we apply and how do we plant and establish some of these small seeded species. What we know from the 4 farms that we worked with is you do not want to plant these CP23 mixes very deep. You want to basically be scratching them into the surface, 1/8 of an inch deep type thing. And then we know that we need to learn more, a little bit more about the adoption and how to get these established and managed as we get to them, right? So it's going to take a little bit of getting used to, but from a row crop perspective, we'll have to make sure that we understand how to use the auto shutoffs and the auto switches on sprayers and things like planters, things like that. So that way we really do capitalize on some of the efficiencies and the profitability things that can occur when we place these on the field edges. So with that, I do want to take a second here to acknowledge our funding source for this. This was funded through the North Central Region Sustainable Agriculture Research and Education Program. Also need to give a huge shout out to our cooperating landowners and survey respondents. Iowa Learning Farms and their research interns helped us do a lot of this as well. And then we had some key people, Greg Schmitz, Liz Ripley, Hillary Pierce, Jamie Benning, and Shannon Schmidt, who really did help provide some great insights and made sure that we were able to get this work done in the field. And then lastly, feel free to contact myself or Adam Janke. We can talk a little bit more about this project or some of the peripheral things around this research. Thank you for joining us today.